Okay, so here is the relearn packet for the last new content test of the year as we begin review. And I'm just going to go through the questions one by one and hopefully illustrate to you anything that you were doing wrong so you can get it straightened out. You got to do all of these questions. You got to copy them down, etc., etc. You know the drill. Okay, so first question here, and it's going to be one long video. Beverly did a study this past spring using data she collected from a cafeteria. She records the data and she makes a scatter plot. Then she draws this particular line. And in the line of best fit, it says that the correlation coefficient, which is right here, R, remember to get that on your calculator, we do make sure catalog diagnostics are on, and then when we do linear regression, it'll tell us the R value or the correlation coefficient. And it says here, what can you conclude? Well, eating more ice cream causes a person to become thirsty. As the ice cream goes up, they do eat more soda, but does it necessarily cause it? I don't know. There's no cause and effect relation. There's a correlation, but I don't know that eating ice cream makes you thirsty in real life, nor from the graph. Drinking more soda causes a person to become hungry. No, not necessarily. Okay, in fact, odds are they probably make you less hungry. There is a strong correlation, that's the R is 0.96, between ice cream sales and soda sales. That is true. And that's choice 2. See, the other ones, if they said there was a correlation, that would be a true statement, but they use cause, and one doesn't necessarily cause the other. Next up. Which recursively defined function has a first term equal to 10 and a common difference of 4? Well, f1 is the first term, and it wants it to be 10, so it could be this guy, it could be choice 1 or 3. Choice 2 and 4, f1 is 4, and we know that that can't be the case. Now, a common difference of 4 means you're going to be adding 4 each time. This is the one that adds 4 each time. This multiplies by 4. That's not what it's going to be. So choice 1 is the correct answer there. Okay, next one up. Data represents number of runs scored by 2 different baseball teams. Which statement is true? Okay, you got to plug this into your calculator. Do one variable stats for team A. Just plug those stats in there, and then do one variable stats for team B. So once again, let me just write down what you need to do. You need to make this L1, and then everybody wants to do one variable stats, and then X bar, when that comes up, that's the mean, and the standard deviation, you can also go over and do the standard deviation. Then once you get those two values, you can write, I'll use X bar, equals, and then standard deviation equals, and then you do the same thing for the other one, but this time you delete the values from team A and you make team B also list 1. You do the same exact thing over again, and then you compare the two numbers. I honestly don't remember what the answer is, and I don't have the time right now to take everything out, but that is how you do it. Okay, next up, which one has a destination with a high median temperature and the small interquartile range, and it wants a median temperature above 80 and the smallest interquartile range? Now, if you're going to be above 80, that means this is your median right here. Now, clearly, Whispering Pines is below, Ocean Beach is below 80. Serene Shores is below 80, see? Pelican Beach and Whispering Pines are both above 80, but the interquartile range is the length of the box. So this is clearly Pelican Beach, the smallest interquartile range above 80. Number 5, the third term in the sequence is 10 and the fifth term is 26. So, see, the third term, first, second, third term is 10, fourth, fifth term is 26. So 26, I'm sorry, I was a step ahead there. You go up a total of 16, and you're going up 2 places, so divided by 2, that's 8. So 10 backwards becomes 2, 2 backwards, 8 becomes -6. And if you notice, there's no choice that is either one of those. but that's because these are written in y equals mx plus b form. So you actually, this is the first term, second term, third term. You have to get the 0th term. And if I go back, I get negative 14. But let's say you stumbled on that. All you need to do is take each of these formulas and plug in, say, 5 for the 5th term, and see if you get 26. In this case, 8 times 5 is 40, minus 14 is 26. And then also do it for the 3rd term and make sure you get 10. 8 times 3 is 24, minus 14 is 10. So this is the only formula, choice 2, that'll check for both of those answers. So if you don't feel comfortable with the analytic way to approach it, try all the choices, see what you come up with. Next up, which statement is true about the data? All right, so we have company 1, we have company 2, and we have their salaries listed here, and there's some things. All right, so let's just try each of the choices. All right, is the median in both companies greater than 37,000? The median is the middle. That's not greater than 37,000, so that's out. The mean in company 1 is greater than the mean in company 2. Well, this one's bigger. That one's bigger and bigger by more. That one's bigger. That one's way bigger. Choice 2 is not right. There's no way that'll be. The salary range in company 2 is greater than the salary range in company 1. Now the range here, ranges highest minus lowest, would be $36,000. The range here would be $6,000. So yes, company 2 has a greater range. Choice 3 is the correct answer. Just a matter of trying all these choices and see what you get. Okay, what's the correlation coefficient of the data here? Well, look, correlation coefficient is a lot like slope. So if I draw my line of best fit, it's going to kind of go like this. No arrow on the end. So there's my line of best fit. Now, clearly that's negative, so the answer can't be positive. Now, 1.0 would only happen if the dots were in exactly on the line. So it can't be negative 1.0. It's negative 0.93, which is still a strong correlation. Christopher looked at his quiz scores, writes them down. Which statement about his performance is right? All right. Let's see here. Again, I don't have the time to do all of this necessarily on the calculator, but here's the 2 things you're going to do for this. You make each list separately like before. Make L1, come up with this data, then erase the data for L1 and do it again, putting this also in L1. And what you're going to look for here is one variable stats, and that will give you the mean, which is X bar. Look that up for each one. And then they ask a couple of questions here about the median. The median is still in one variable stats. You just have to scroll down a little bit more. You'll see it'll say MED. And then it'll also be the first quartile, and then the 3rd quartile. So if you just do that with one variable stats and you write down the mean, the median, the first quartile, the 3rd quartile, and then you erase those numbers and you do the same exact thing again, by erase I mean erase in the calculator, do the same exact thing again for semester 2, and then compare your answers and see how that relates to the 4 choices, you will be able to get them right. Number 9, the graph of the function is shown below. It says domain. Domain is the set of all x values, the inputs. Notice this is a closed circle, so it does include this point, and everything going this way is included. So that's x is greater than or equal to negative 4. Choice 4. For number 15, if f of x is 3 to the x and g of x is 2x plus 5, for which value of x is f smaller than g? So what I'm going to do here is this. Negative 1, 2, negative 3, 4. And then I'm going to do f and g and see what I come up with. All right, and you can do it right in your calculator. For f, if you plug in a negative 1, you're going to get 0.3 repeating. And for g, you're going to get 2 times -1 is -2, plus 3 is 5. Clearly, f, it wants f is less than g. 0.3 repeating, 3 to the -1, 0.3 repeating, and then 0.3 is less than 3, so the correct answer has to be choice 1. I'm going to try 4 just to show you that 4 does not work. 3 to the 4th is 81, and 2 times 4 is 8, plus 5 is 13. So it would not work. So you try the choices and make sure you get only the one that works. Choice 1 is it. Okay, next is the zeros of the function r. A couple of different ways to do this. You could graph it and see where it crosses the x-axis, or you could solve it. And I don't want to get the graphing calculator out now, and if you choose that method, I'm sure you're good at it. So first I notice they have a common factor of 3, so I factor that out. And then I go and I factor the trinomial. Maybe it's the guy on the left, maybe it's the guy in the middle, maybe it's the guy on the right. It's not the guy on the left, that'll never happen, cross it out. Add 2, x is 2, subtract 1, x is -1. So 2 and -1, choice 4 is correct. As far as number 11 goes, let f be the function. F of x is 2x minus 4, defined on the domain. Notice x. Very important to notice that. X goes from 2 to 6. What's the range? So you go in the calculator, you type in y equals 2x minus 4. Then you go to the table, you get blah, 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 and in between you will find a section that goes 2, 3, 4, 5, 6, and then you go out here and it'll say 0, blah, 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 8. So the domain 2 to 8, 2 to 6 matches up with the domain of 0 to 8. So choice 1 is the correct answer there. Okay, next. Show won't work for each question, blah, blah, blah. Okay, look, the easiest way to do this particular question is to put the information into your stat edit, and on list 1, you're going to go 1, 2, 3, 4. On list 2, you're going to put these in. And what you should notice right away is that you go up by 60, you go up by 90, you go up by 135. This is clearly exponential. So you put those values into the calculator and you type in exponential regression and it will tell you the answer. Okay? Now, how could you also do it? Well, there's a couple of ways to also doing it. Since it's exponential, it's y equals a, and this is exactly what the calculator would do for you anyway. Y equals a times b to the x. And there are actually 2 different answers you could get here. A is the amount that you started with. So you could say y equals 120 times, b is the common ratio. The common ratio here is 80 divided by 120, 270 divided by 180. It's all going to be 1.5. But then you have to write to the x minus 1. That is equivalent. It is the same as if you said, well, I want to go to the 0th term, and let me go backwards, and if I do that, and I divide by the 3/2, I will come up with 80. So that's the same exact answer as y equals 80 times 1.5 to the x. Both of those answers are completely acceptable. This is the one that the calculator will come up with. Either one of those is correct, though. Next, it says predict how much would be in the 26th week. All you're going to do is take either formula, plug in a 26, it's over 3 million, and then it says, is it reasonable? And everybody seemed to have a big problem with that one. It's not reasonable, because if you plug in a 52, you get some astronomical number that is a digit followed by 11 zeros or something like that. There are not that many people in the world, let alone in the United States, to get this particular app done. So it's not a reasonable answer. And there is a point in time at which this particular model fails. Okay, next one. Construct a box plot. Okay, so here's the deal with the box plot. Most people did really well, a few people didn't. First off, you notice that the highest answer here is 5, lowest answer is 1. So I'm going to go 0, 1, 2, 3, 4, 5, 6. Then I'm going to put each of these values. Now, some people put them in 3 different lists. It's not 3 different lists. It's all one list. I don't care. It says here, watch Sunday through Thursday for 3 weeks. I want to know for all of it put together. They don't want one box plot for week 1, a different box plot for week 2, and a third box plot for week 1. They want one big box plot that has all of this data in it. So what do you need to do? You need to put all of it into list 1, and then you need to do one variable stats. When you do one variable stats, you then look up and scroll down until it says minimum, first quartile, median, third quartile, maximum. Now, once you find those values, I'm just going to take some guesses here. This is not the actual values because I'm not going to take time to put them in the calculator. But the smallest value I see here is 1 and the biggest is 5. Those should be accurate. Let's say that this is 1.7, 2.3. I think my pen's starting to die here. And 3.9. I go over here and I make a mark at 1. I make a mark at 1.7. I make a mark at 2.3, I do 3.9, and I do 5. Here are my whiskers, and there is my box. So there's your box plot or your box and whisker plot, however you want to look at it. The key is enter all 15 pieces of data into one list. Do one variable stats, scroll down until you see what it tells you the minimum, first quartile, median, third quartile, maximum are. Make dots at each of those values, and then you do your drawing. Bink, 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 bink. Okay? All right, so that's the scoop. That's what you got to get done. Oh, boy. Oh. I'm trying to find the right spot on the worksheet here. Here we go. Caitlin has a movie rental card worth $175. After she rents the first movie, the card's value is $172.25. Second movie is $169.50, and so on. Assuming the pattern continues, write an equation, A sub n, for the amount of money in the car after n rentals. Okay, so you began with $175. And each time you rent the movie, you're going to subtract $275. So the equation is 175 minus 2.75 n. Caitlin rents a movie every Friday night. How many weeks can she afford to rent the movie using her rental card only? So you can only rent until you get to 0. So 175 minus 0.275 has got to be greater than or equal to 0. Minus 175 from both sides. And I'm going to come up here because the pen seems to be writing very poorly down low. Negative 2.75 n, almost forgot that, is greater than or equal to negative 1.75. Divide by negative 2.75. And you know what? I don't have a calculator at the moment, but I think it's like 63 point something. So it says, it comes out, I think it comes out to, you have to do division on your calculator, but off the top of my head, I think it's 63 point blah, blah, blah. Which means if that's the case, she could rent 63 movies. She could not rent 64 because then you would go past 0. All right, I think that's what the division works out to. You can figure that out on your own in case I happen to be wrong. All right. Oh, come on, will you please? All right, now we get to the residuals question. Table below represents the residuals for the line of best fit. So we go to 2, 2, 3, 1, 3, negative 1. Oh, sorry, 3, negative 1. This is not a point right there. Cross that off. 4, negative 2. 6, negative 3. 5, 6, negative 3. 7, negative 2. 8, negative 1. 9, 2. 9, 0. 10, 3. Now, it says next, is this a good line of best fit or a poor line of best fit? It is poor. The reason it's poor, now you don't want this on your graph, okay? But I'm showing you why. Again, you don't draw this on your graph, but if you look at it, there's a pattern to it. Whenever there's a pattern, it's a poor best fit. If it's a pattern, then it's poor, okay? Okay, attendance at museum, linear regression. All right, so this is just a matter of going into the calculator. So when you go into the calculator, this is going to be L1, this is going to be L2. The question is, what do you put in there? And it wants you to notice this. It says when x is 0, so this is really 0, 1, 2, 3, 4. Don't put in 2007. Put in 0, put in 1, put in 2, put in 3, put in 4. And when you do that, you will get a line of best fit that comes out. Go to linear regression, type in line of best fit, and then look, make sure your diagnostics are on, look for where it says R is. And whatever it says R, oh, and by the way, going back to here, make sure you round to the nearest hundredth. Whatever it says R is, that is your line of best fit, okay? I know I could be showing you each step of this on the calculator, but I'm really confident that you know how to do it. You knew how to do it in class. I think it's okay now. If you really do struggle with it a little bit more, bring it to me, and we'll see what's what. Okay, state the domain and the range. Now the domain is the x value. So the domain will be between two numbers, and the x's go from here to here. And it is allowed to equal it because they're solid dots, and that's going to go from -5 to 2, 4, 6, 8. So -5 to 8, I think it's 8. 2, 4, 6, 8, yep. That would be your domain. Now we're going to do the same idea with the range, except the range is not x, the range is y. Notice they're solid all the way across. So again, I use these symbols. And the range goes from, here's the lowest range number because range is y, up to there. So it goes from -3 to 2. Now you could also express this like this, using bracket notation from -3 to 2. And this guy we could write -5 to 8. You should recognize and be fluent in both notations. The number of houses is represented by this particular function, blah, blah, blah. Years since 1995. Suggests a new well must be built. Where does it exceed 1,000? Okay. All right, so look, there's a couple of different ways to do this. Probably the easiest way for your purposes is to graph it. And when you graph it, graph will look like this. So what you're going to do now is it wants to know when will it exceed 1,000. So then go to table, and when you go into the table and you look for the first year in which the total number passes 1,000. Okay, and then whatever that year is, during which year will this first happen? You got to figure out that year. Let's just say, for argument's sake, that it worked out to be year 10. I don't remember what it works out to be, but whatever it works out to, since this is 1995, then I would add 10, and the answer would be 2005. A lot of people just stopped with an answer like 10. So you need to work it out, look in the table, see what year you finally break past 1,000, add that number of years to 1995. For some reason, the number 13 is sticking in my head and an answer of 2008. I really don't know, but you could check it out. That's the way to do it. And lastly, number 20. Oh, you know, I just knew that would have to happen. The height of a ball will reach in the air as a function of time, t seconds given by that equation to the nearest tenth. All right, look, the problem that the kids experienced on this is they did not, they weren't specific enough. If I graph this guy, it's going to look something like this. It's thrown from 6 feet and above. You need to find this maximum point here. And what people did is they looked on the table and they looked for the biggest number. The problem with that in using the table is that the table might give you the point here and not necessarily the max in the middle. So what you need to do is you need to go to calc, then on calc you're going to do maximum, and then it'll give you a little blinking bug on one side. It'll say left bound, you say enter. Then it'll give you a little blinking bug on the right side. It'll say right bound, hit enter, then hit enter one more time. And at the bottom of the screen, it'll say x equals, whatever x equals, I don't know what it equals. And then y equals. That, the y equals, is your maximum height. And that's what you want to get out of the deal. Okay? All right, so that's how we do every single question on your test. Now that you know how to do them, let's practice some more and get ourselves ready, not only to bring up our test grade on this should you need it, there were some excellent grades, but also because by learning this, you will be learning your Regents exam work, okay?